So we are going to continue here with properties of transition elements. We'll look at copper. I would also want to introduce 4Keys College online seminars. So if you want your school to participate in our online seminars, you can contact me on my WhatsApp number. We'll be having WhatsApp groups. We'll be discussing some very important topics in chemistry. We'll be doing some exam coaching online and exploring various topics and concepts that are important in our study of A-level chemistry. So you can contact me so that you participate in these free online seminars. Okay, so let's begin here. So let's look at a problem where you have to figure out the percentage of copper in a copper alloy. So what you simply have to do is dissolve the copper. So copper will react with iodide ions, and it will be able to oxidize iodide ions according to this equation here. So when you dissolve your copper according to those steps, you have to react with your iodide. So when it reacts with your iodide, it's going to form a copper 1 precipitate and also some aqueous iodine. So what you have to do here in order to figure out the amount of copper that was present is you take the iodine that was produced and react with thiosulfate ions. So you use sodium thiosulfate to find the number of moles of iodine that were present. So this is according to this equation. So the iodine produced there can react with thiosulfate ions of a known concentration and volume. So we can know if we are given the information concerning our thiosulfate, which is the number of moles and the volume, we can calculate, if we're given the concentration and the volume, we can calculate the number of moles of the thiosulfate. And from that reaction, we can figure out how much thiosulfate reacted with our iodine, and we can then use the ratio of the iodine to the copper. So we have a 2:1 according to this equation that we are looking at. For every 2 moles of copper, we form 1 mole of iodine. So the thiosulfate equation will help us to figure out how much iodine was there, and from the iodine that was there, we can figure out how much of the copper was there. So that's the logic. So if you work out the number of moles of iodine that were produced, you do this using your thiosulfate, and you can now calculate the concentration of the oxidizing agent, which is the concentration of the copper. And if you know the concentration, you can calculate the mass of the copper in the original sample, and we can calculate the percentage of the copper that was in the alloy. So I have put a link in the description of a video that I did where I was calculating, I was doing an actual examination question that involves this concept of iodine and thiosulfate and the titration problem. So I would want you to check those videos, check out the links that I've put in the description. There are some errors that you need to check out for, which is when to add the starch indicator. As you carry out the titration, there's going to be a precipitate that is formed, a white precipitate of copper 1 iodide, and this makes it difficult for you to see the end point. And what you have to do is you have to add starch, which is going to react with the form a complex with the iodine that would be present in that solution, and this blue complex will guide you as it disappears. When it completely disappears, you know that all the iodine molecules that were there would have reacted. So starch will help you to figure out the end point as you approach the end of that titration. So all these dynamics, all these things are discussed in that video. So please go and check out that video. And also don't forget to tell a friend to participate and join our online seminars. So I'll meet you in the next video.